This video will discuss chapter 9.1, graphing quadratic functions. So what we're going to focus on is how is it that we might graph something that looks like this. So we got y equals 3x squared plus 6x minus 4. So what I'm going to do is take negative 2, and I'm going to substitute it in for both places you see the x. So negative 2 times negative 2 is positive 4. 4 times 3 is 12. So I've got 12. And then negative 2 times 6 is negative 12 minus 4. So this is 12 minus 12 minus 4. So this is going to be negative 4. Then take negative 1. Negative 1 times negative 1 is positive 1. 1 times 3 is 3. Negative 1 times 6 is negative 6. And then negative 4. So now I'm going to go 3 minus 6 minus 4, and so this is negative 3 minus 4, so this is going to be negative 7. Substituting 0, 0 plus 0 minus 4, so this will give me negative 4. And then 1 times 1 is 1, so 1 times 3 becomes 3, plus 6 minus 4, so this is 9 minus 4, so this is 5. And then 2 times 2 is 4, times 3, this is 12, plus 6 times 2, which is 12, minus 4, so this is 24 minus 4, and this is 20. Now, I want you to see that it didn't necessarily use a calculator, and if you do, you really shouldn't be typing things in all at once. You're just kind of going one at a time. And now what I'm going to do is I'm going to take these points, I'm going to put them on a graph. So if you look at that, I'm going to go negative 2 comma negative 4. So that would be, let's go this way, negative 2, and then down 4 will take me to here. Negative 1, negative 7. So that's 4, 5, 6, 7. That would be here. 0, negative 4 is going to be here. 1, 5 is 1, 2, 3, 4, 5. 1, 5 is there. Okay, and then I want you to know that the 220 is one that I'm not going to be able to put on the graph. And I purposely picked a point like that that won't fit on the graph so you kind of see exactly how that would work. So, coming back to that in just a second, I want you to see that what I did was I took each of these points, so this is x comma y, going across. Right, and so I put that here. Now as I create this, remember this is going to create a U, and so it's going to look something like this. Okay, so that would be how I might graph y equals 3x squared plus 6x minus 4. So to do that, what I would do is take each of these, I would substitute in values for x and for y. Okay, now I purposely picked these 5 values. Realistically in the book, they picked negative 3, negative 2, negative 1, 0, and 1 because those would work out better, but I didn't necessarily want to pick those because I felt like that was kind of cheating because I would have known where it was coming out. So I would typically pick 5 numbers like this, just try to figure out where it's going to go. Okay, and so then my graph looks like this. Now I'm going to erase this because I'm going to have to actually use this graph board for a second problem in just a moment. So let's first though talk about some of the properties. So I'm trying to multitask here and draw a graph and it's not working out for me. Let's talk about some of the properties of these types of equations. So first let's talk about the graph, which is a parabola. Okay, and so the parabola is going to be kind of a U, and it's going to be symmetrical, and it's going to have an axis of symmetry, right? This is the line of symmetry, so theoretically I could fold over that line, I should get the exact same thing. And then we'll have a vertex, which is the lowest point, or if this is an upside down U, it would be the highest point. But it's kind of the point where the U essentially turns. Okay, and so it's really important to know the axis of symmetry and the vertex, and there's ways that we can figure that out. Okay, and so the formula, keeping in mind that if the equation is in the form of ax squared plus bx plus c, the formula to find the axis of symmetry is that x equals negative b over 2a. And so I'm going to come back to this in just a sec. You're getting a line that goes straight up and down like this. So a line that goes horizontal like this is going to be y equals 1, y equals 2, y equals 3. lines going this way are going to be x equals 1, x equals 2, x equals negative 4. So just x equals is the graph of the line. So this will give us, this formula will give me the graph of the line of the axis of symmetry. The y-intercept is going to be at 0, comma c, so I'm going to use that number. It's going to be at 0, comma that. And then to find the vertex, it's going to be this x. The line of symmetry, the axis of symmetry is the value for x. I'm going to substitute that in here. I'm going to find y, and then I'll know what x comma y is. So I want you to see that the vertex, right, the vertex is actually along the axis of symmetry. The axis of symmetry goes straight through the vertex. So this vertex, let's say that this was x equals 2. This would have to be 2, comma something. If this was x equals 5, this would be 5, comma something. If this was negative 1/2, it would be negative 1/2, comma something. And so what I'm going to do is take that x value and determine the y. I'll show you exactly how we're going to do this. Let's say for something like this. So, to find the axis of symmetry, I need to go x equals negative b, which is that, so 4 over 2 times a, which is 2. So this is going to be x equals negative 1, right? Because it's going to be 4 over 4, or negative 4 over 4, so that'd be negative 1. So my axis of symmetry will be negative 1. The y-intercept is going to be at 0, comma c, and c in this case is negative 3. I want you to see how this one's negative 3, right? Because of that, it's not a positive 3, it's a negative 3. And then the vertex, to find the vertex, what I'm going to do is take this number. So my vertex I know is going to be at negative 1, comma something. I just don't know what that something is, so I'm going to take the negative 1 and substitute it in. So it's going to be 2 times negative 1 times negative 1 is 1, plus 4 times negative 1 minus 3. Okay, now I'm going to run out of room, so I'll lift it up a little bit. This is going to be 2 minus 4 minus 3. This is negative 2 minus 3, so this is going to give me negative 5. So my vertex is going to be at negative 1, comma, negative 5. So I now know the vertex, I now know the y-intercept, and I know the axis of symmetry. And so what I can do from this point is be able to graph from there. I want to show you how it is that you might do that in just a second. So let's take another equation, like say this one, and I'm going to graph this equation. Okay, so the first thing I want to do is find the axis of symmetry. So the axis of symmetry, I'm just going to call this 1. So the axis of symmetry is going to be at x equals negative b, b is 4, over 2 times a, which is 1. That means this is going to be at negative 4 over 2. So it's going to be at x equals negative 2. That's my axis of symmetry. You often want to find this first because I need this number to help me find the vertex. Now, a lot of books will tell you to find the vertex, or to find the vertex next. I usually end up finding the y-intercept because the y-intercept really takes no math skills other than identifying what c is. And so I like to get that one out of the way so I don't accidentally make a mistake and let something kind of sneak in there. And now to find the vertex, I'm going to take this value and substitute it in. So I got y equals negative 2 times negative 2, that's 4, right, because I'm making negative 2 squared, plus 4 times negative 2, so that's going to be plus negative 8, plus 3. So y equals 4 that's a y. 4 minus 8 plus 3, that's negative 4, plus 3, that's negative 1. So this is going to happen at negative 2, comma, negative 1. All right, so now I'm going to hold up a sign. That's showing you the work. Rewind if you have to, but here is the numbers that we're using. Okay, and what I'm going to end up doing now is taking this, and I'm going to put this onto a graph. So let me show you exactly how that would work. I'm going to come back to this in a moment. So the first thing I want to do is take that axis of symmetry, which we were saying is at negative 2. Right? So this is 1, 2, and so what I'm going to do is create a dotted line going all the way up and all the way down. So now I know that's where my axis of symmetry is. I know the y-intercept is at 0, comma 3. So that's 1, 2, 3. That goes here. And I know my vertex is at negative 2, negative 1, which is going to be here. All right, now if this is a line of symmetry, remember that means that I can take this and I can fold it over. So what I'm allowed to do then is take this point, which is 2 off of right? So this point now is 2 off of the axis of symmetry, right? 1, 2. And I can go along this same y value, I can go 2 over. 1, 2, which would put me here, right? So without necessarily substituting in, though you could substitute in, and if you substitute -4 in to the equation, you'd find out that it actually equals +3. Okay, but at this point, I now have my 3 points. And a lot of times what they'll tell you to do is find another point. So you could find, like, for example, what happens if I substitute 1 in? So I'm coming back to this original equation. If I were to take a 1 and substitute a 1 in here, or you could take a 3 and substitute a 3 in here, and find another point. So let's say I did do 1. You go 1 squared plus 4, so this is 1 plus 4 is... 1 plus 4 is... why am I blanking on this? 5 plus 3 would give you 8, and you could find this where the point for 1 is, right? So that would be like all the way up here. So let's do that one. So 1 plus 4, we said is 5, plus 3 is 8. So that would be, there's 3, 4, 5, 6, 7, 8. So 1, comma 8. Now that is 1, 2, 3 off, so I could go 1, 2, 3 to here. Right? And at this point I now have 5 points along my parabola, and so that is what my graph is going to look like. So a lot of times what you're going to want to do is find that next point, and I would use this to figure out what you could do. You could also use -1, figure out where -1 would have been, and I could have then used that, but getting a higher point than, say, this helps me kind of determine the steepness, I guess, of the parabola. All right, I know that was a lot of information I just threw at you. That's all I got for you, though, on graphing quadratic functions. Thanks very much for watching the video. Don't forget to do the problems on the bottom page. See you in class.